Today we're going to go on an excursion to absolute value inequalities. So polynomial rational inequalities involving absolute value can be solved by either of the two graphing methods, right? So some of them can be done algebraically, some of them graphically. Anytime you have anything larger than a quadratic, graph. Okay? Anytime you have something larger than a quadratic, make sure you graph. All right, so the first one here, we're going to use the intersection method to do that. So get your calculator out, put the left side in y1 and the right side in y2. Yep, you are putting in absolute value. Now, one of the things when you're using intersection would not be a bad idea to draw it on your paper so that you can see it there. So then you're able to write on it. Okay. So I'm going to go ahead and copy this onto my paper. Yeah, just do a nice sketch. Doesn't have to be perfect, just a nice sketch. Now, once you put your sketch on your paper, then you're going to want to make a number line. To work with. Okay. So in the number line I'm working with here is going to be totally centered around the intersection points. Okay. So the intersection points here, I can't quite tell what they are right at the moment, but I know that they're between 0 and 3, right? So I'm going to use 0, 1, 2, and 3 is all I'm going to need on my number line. So I need to find those two intersection points. Okay. So second trace, number 5, and the first one is at point 466. So that's approximately here, about 1/2. Okay. That one. All right, so I need to find the other one. Second trace, number 5. And I need to move closer to that one then. And we get 1.52. All right, so that's about here then. Okay. Now, All right, so we got those marked, right? Oh, excuse me, I marked those circles wrong, because those should be open. So the question is, when is the absolute value part, the left side, less than the right side? So I'm looking for when the curved line is bigger or the straight line is bigger.
Straight.
Okay, the straight line is bigger. So is the straight line bigger between those 2 points or outside of them? Okay, now, so here's the thing. If it's bigger, that means it's higher on the graph, right? When is the straight line higher on the graph than the curved line? Okay, all right. Between them or outside of them? Between them, right? Okay, because between them, the straight line is above. Okay, so red is above blue on here, so then I'm going to fill in between those two. Now, how could I check that? What would be the number I would use to check it? Okay, in this case, 1. All right, so we get 1 plus 1 is 2, and 2 minus 2 is 0, so is 3 less than 5 times 1? Yes, okay, so it should be the area between them then. Okay, always good to check a point if you are questioning yourself. So in that process, I'm hearing people say both things, so very important to pick a value and check it to see if it works or not. You should write these with one form or the other of the either using interval notation or inequality. So here I could say then that 0.466 comma 1.52 parenthesis. What? Because it says less than. Okay, there's no equal to. All right. Okay. Number 2. Solve the absolute value of x plus 3 over x minus 1 is greater than 2. And this time we're going to use the intersection or the intercept method, x-intercept. So to use the x-intercept method, we need to do what? All right, by itself. So we're going to start by subtracting 2. So we have the absolute value of x plus 3 over x minus 1 minus 2 is greater than 0. So now all we're doing is looking for what?
X-axis.
Okay, when it intersects the x-axis and then above that. Okay. And don't forget the fraction bar is on alpha y equals. Make sure you use the fraction bar. Unless you're Jacob, then you've got to use lots of parentheses. So it's not a big deal. You just need to make sure that the numerator and the denominator are in parentheses. Okay? All right? Alpha y equals. All right. All right, so you would have ABS parenthesis x plus 3 close the parenthesis, open divided by parenthesis x minus 1, close the parenthesis, and then close another parenthesis, and then minus 2. All right, did you do it?
I've done that.
Okay, all right. All right, so we graph it. It looks like this. Okay.
Come back up.
Now, good idea to sketch it, yes. Okay. This is a little trickier. Why is this trickier? Because they don't touch till they're fuller up, okay? Till they're farther up. The problem with that is, no, it's not that you can't see it. You can't see it because it doesn't happen. All right, they don't touch. Anybody know why they don't touch? Anybody know what value that is of x where they don't touch? Okay, at positive 1, they don't touch. Why? Close. Yep, because that's where the denominator equals 0, and we have a vertical asymptote there, so it's undefined.
It's in there, right?
No, you have a negative 2, not a minus 2. All right, so when I look at this, all right, we have an asymptote here at x equals 1, so there's a vertical line drawn here through x equals 1. So that means that I have 3 critical values now, okay? I have the 2 zeros and where the vertical asymptote is, where the denominator equals 0. So when I draw my number line, I'm going to need to have all 3 of them marked. All right, so let's see, the first one is between negative 1 and 0, so we'll go negative 1, 0, positive 1, and then this one down here looks like it's about, what, 5? Okay? So, once again, it says greater than, so we're going to have open dots at our first one, which is going to be just to the left of 0. An open dot at 1, because that vertical asymptote is not an exact value. And an open dot down here, is that 5 exactly? It is? Okay. All right, at 5. So it's greater than 0 everywhere between them, right? And the only problem we have is because of the asymptote. So what happens is that it's going to be here and here, but we just have to recognize that there's an open dot at positive 1. So when I verbalize it, all right, we have to verbalize it with an or between these 2 parts. Okay. So what is the one less than 0? Negative 1/3? Okay, so we've got negative 1/3 here at 1 and at 5. So when I express this with interval notation, we have parenthesis, negative 1/3, comma 1, or parenthesis 1, comma 5. So you have to recognize when that happens. Okay. Easy stuff, right? Okay. All right. Just got to be careful of that. All right, let's do it algebraically now. Now, here's the thing, okay? Absolute values. When you were solving the absolute value equations, what did you do algebraically? We wrote what was in the absolute value. We said it's equal to a positive and a negative, right? Okay, now, what happens when we're working with an inequality, though, then, and we go to a negative? Yes, we have to change the direction of the inequality sign when we go to the negative. And I'll show you exactly why that is. Okay, so here we've got absolute value of 2x minus 5 is less than or equal to 8. We drop the absolute value and we use what it is. Okay, now I made it pretty clear that, you know, when we do it, we say, hey, change the sign, right? Okay, but here's the thing. Here's what actually happens, is that when they do this, it becomes here's what they say mathematically happens, okay, is that what becomes negative is what was in the absolute value, okay? Well, what happens then when I get rid of this? What do I have to do to get rid of this negative sign here? Okay, we have to divide by -1 or multiply by -1, and so that when I do that, then, because I've multiplied or divided by a negative, I have to change the direction of the inequality. So if you just remember to change the direction of the inequality and change the sign, you're okay.
Only when it's an absolute value?
Yes, just the absolute values. Yeah. Okay. All right, so then we need to solve both of those inequalities. So here's a situation where the smaller number is in my right-hand inequality. And so you got to make sure that when you write them, that you write them with smallest number first. Now, here's the thing again, all right? What's the symbol? Okay, less than or equal to, right? All right, less than or equal to. So we're going to have brackets, -3/2, 13/2, and bracket when we do with the interval notation. Just Jordan asked, can I write it as a compound inequality instead? And right now I don't care. All right, I will tell you what I want on the quiz and test and like that. And so, and mostly I'm going to want you to do it all three ways there. So you need to be able to do all three ways. And why? Because when you get more stuff or on SAT and like that, you could see interval notation and people forget how to do that. And so you need to be able to know all of them. All right. Is this the one you got for number 4?
Yeah.
Okay. All right. Okay. So go ahead and do that one. When we have a quadratic, it becomes a little bit more difficult to do it just because what? What does a quadratic look like when it's the absolute value of a quadratic when you graph it? What happened when we looked at it yesterday or the other day graphically? What did we see? It looked like a specific letter. Yeah, it looked kind of like a W, right? Came down, went back up, curved, back down, and up. So it looks something like this. Okay? Well, if the other side of this is 5, right? So how many answers could I possibly have? 4 of them. Okay? So it gets a little bit more, or a little trickier to make sure you have all four and writing it the correct way. So let's take a look at what we might get. So x squared plus x minus 7. And right now we're going to focus on equals, okay? We're going to completely ignore, well, no, we won't. I'm going to write it first of all, and then we'll do that. Right? But since we're working with quadratics, we need to find the zeros. Okay? So we need to get everything on the same side, and hopefully we can factor. All right? And if we can't factor, then we're going to have to complete the square or use the quadratic formula in those cases. So let's see. X squared plus x minus 12 greater than or equal to 0. Awesome. That one's factorable. Okay, we're good. X squared plus x minus 2 less than or equal to 0. Super. They're both factorable. We're in business. All right, we don't have to complete the square, do the quadratic formula. So find the zeros and graph them on a number line once again. Okay. So on my number line, I must have all four zeros marked. So we've got -4, +3, -2, +1. So I need to go from -5 to 4. Okay. All right, it's greater than or equal to, so I'm going to put solid dots at all four of those zeros. Okay, and so we're going to test numbers between them to see if they work. Where are we going to test them? In the original equation. All right, I'm going to use my friend 0 first because I like him the best. All right, so we're going to check 0. So is -7 greater than or equal to 5? No. Is the absolute value of -7 greater than or equal to 5? Yes, it is. Okay, so this one works. So we're good there. So we know it's going to be the area between these two. Now, generally, okay, right? And I use that word because I didn't use the word always, right? Generally, if that's the case, then it's going to be here and here also. Generally, okay? But it doesn't always work that way, so we need to test other numbers to make sure whether they work or not. Okay? So, we're going to test -3 to see if it works, because it's between these two. And if that's the case, then it should not work. Right? So -3, I put it in up here. And I get, I'll write it down here, 9 minus 3 minus 7, absolute value, is that greater than or equal to 5? All right, -3 squared is 9, minus 3 minus 7. So it's 9 minus 10, -1. Is -1 greater than or equal to 5? No. Okay, so it doesn't work there. Good. I'm okay. that means it's got to work out here then. Okay? You can test -5 if you want, but it'll work. All right, let's check 2 also. All right? So 2 squared is 4 plus 2 minus 5 is minus 7, excuse me. Is that going to be greater than or equal to 5? No. Okay, because 6, so we get -1, so it's not. So there's our answer. Okay, when we write it on a number line. Okay? So how do I write it the other way then? You just have to make sure that you have ors in it. So I'm going to write it both ways then for those of you who would like to see it both ways. Right? So compound inequality. X is less than or equal to -4, or X is greater than or equal to -2, less than or equal to 1, or X is greater than or equal to 3. There's the compound inequality. You have to take into account all 3 parts, separate them with an or, with the word or. And as an integral notation, it looks like that. Oops, sorry, too far. Is that the last one, Andrew?
Yeah.
Okay. Yep.